Hello everybody, my name is Gita Soumit. I am from VVD College. So today I am going to discuss about computer organization topic, that is nothing but sequential multiplication. So generally we use this sequential multiplication to multiply two the binary numbers, whether it may be generally it may be signed or unsigned, but we use this multiplication to multiply two binary numbers. So we can multiply two binary numbers by using normal multiplication method, that is nothing but we use normal multiplication method that we can also use for same binary numbers, but there are certain algorithms given for us to multiply two binary numbers. So let's discuss about this topic. So let's dive into the first, what is meant by, as we have know that it is an algorithm. So there are four steps in the algorithm for sequential multiplication. The first step is nothing but consider a carry bit as 0 and accumulator as 0. So these are two variables. Let us consider a carry bit and also an accumulator bit having both zeros, whereas accumulator can have the value. Accumulator is nothing but it has the digits. Number of digits in accumulator can be determined by having number of digits in a queue. So let m be the multiplicand and q be the multiplier. So number of digits in the queue will determine number of digits in accumulator. So determining is nothing but number of digits in queue will be equal to number of digits in accumulator. So if there are four digits in queue as in multiplier, then will be a four zeros in accumulator, as we need to take consider zero initially in accumulator. So q naught is nothing but the rightmost bit of q. Let us consider q naught be the rightmost bit of q. If q naught is 0, then we need to perform just a shift right operation. If q naught is 0, then we need to perform only a shift right operation. Just a shift right, not a logical shift or not a rotate or any arithmetic shift. So that is what we call CAQ, carry bit, accumulator, and also multiplier. We need to shift towards right. And when this is done, when q naught is 0, when q naught is 1, we need to perform a plus m and store it in a. When q naught is 1, we need to perform a plus m and we need to also store it in a. After storing it in a, we need to perform again the right shift operation. So I have not mentioned here, but after after performing a plus m, again we need to perform a right shift operation, same CAQ. So when the q naught is 0, then we should perform only a right shift operation. When q naught is 1, we need to perform both a plus m and also shift operation. So here you can see that the flowchart for the algorithm of sequential multiplication. So generally start accumulator, as we see in here, accumulator and both carry bit are taken as 0, a equal to 0 and c equal to 0, m be the multiplicand and q be the multiplier. Step 2, and now we are considering q naught. Q naught is nothing but the rightmost bit of the queue. When q naught is 0, then we are performing a right shift operation. When q naught is 0, as it is not equal to 1, we are performing a right shift operation. When q naught is 1, we are performing a plus m and storing again in a. So that's why here we have given a equal to a plus m. A plus m and store it in a. And again we need to perform a right shift operation. So after this a plus m, we have arrow marks which points the to perform a right shift operation. So in this way the flowchart occurs, and we after the one more important point is that we need to also consider the number of bits in q. So if q is a 4 bit, then we also contain 4 bit. We will consider n value as 4, and we perform this operation until n value becomes 0. So whenever you perform a right shift operation, decrement the n value. So as I have not mentioned in the steps, but it is our necessary precaution we need to take. N value, after every right shift operation, we need to decrement the value of n. So this is about a flowchart of sequential multiplication. So let's see an example. So example is nothing but to multiply two binary numbers 0101 and 011. So by using sequential multiplier algorithm. So how we can multiply two binary numbers by using sequential algorithm. So let's see. Generally the solution is as follows. We need to consider a table. The table structure can be a good understanding, can bring a good understanding. So let's consider a table where initial C and A are 0. As we consider C value and A value, as we know that A value is nothing, A value is taken the number of bits in a queue. As Q given is multiplier is 0, 1, 1, 0. It contains 4 bits. So we have also taken A value as 4. As Q naught, so you can see here the rightmost bit of the queue is 0. So we need to perform a shift operation, shift right operation, and we need to decrement the value of n. So initially n is 4. I have not mentioned, but n is 4. After performing shift right operation, we need to decrement the value of n. It becomes 3. So shift right operation is nothing but we need to move all the values to the right side. So the one here comes here, and all the digits moves towards right side 1 bit. After performing shift right, then we need to again perform and we need to again see what is the value of q naught. Here the value of q naught is 1. Here you can see that the value of q naught is 1. As the value of q naught is 1, we need to take a plus m. So as a is 0 and m is given as 0, 1, 0, 1, we need to add both a and m and show it in a. So 0, 0, 0, 0 plus 0, 1, 0, 1 gives 0, 1, 0, 1, and we have stored this value in em. We have not changed any value of c and also any value of q, just perform the a plus m. We have not also we have not decremented the value of n because we doesn't not perform any shifted operation. So according to the flowchart, after performing a plus m, we need to again right shift the operation. So I have, after performing the a plus m, I also perform right shift operation and decrement the value of n. The tree becomes 2 and the right shift value comes here. So every digit will be moved to the right 1 bit. After moving again, as the n value is not equal to 0, consider again the operation q. Let's consider q naught. Q naught value is 1. So again perform a plus m. Initially the a was at this instance the a value is 0, 0, 1, 0, and just add the multiplicand 0, 1, 0. After adding 0, 1, 0, 1 with a, we will get the final value of a as 0, 1, 1, and this 0, 1, 1 is we get the 0, 1, 1 after performing a plus m. So according to the algorithm, after perform a plus m, we need to again perform a right shift operation. So after performing a plus m, the way final a value is this, and we need to perform right shift operation, decrement the value of n. So at this instant the value of n is 2 and it becomes 1. Shift right operation performs it takes the value of, if shifts the value all the bits to the right side. As the value of n is not equal to 0, again we need to perform this operation and check whether q naught is 0 or 1. Here the q naught value of 0 is 0. So as q naught value is 0, we need to just perform a right shift operation and decrement the value of n. So 1 becomes 0 and we need to perform right shift operation. So right shift operation, every bit moves towards right side. So CAQ moves towards right side, and this becomes our final answer, because we will stop the algorithm here because the value of n is 0. As the value of n is 0, we can stop the operation, and the final answer is given by AQ. Both A and Q combined will get an answer. So for example, let's change these binary bits into integers. So 0101 is basically nothing but 5 in decimal, and 0110 is nothing but 6 in decimal. So multiplying 5 and 6 will get 30 as an answer. So you can observe both A and Q combines to give the value of 30. So this value is nothing but 30. So this is about simple sequential multiplication. So sequential multiplication is generally used to perform binary numbers multiplication. So it has an algorithm. Let's again recall the algorithm. Consider a carry bit and accumulator as 0, where accumulator is nothing but it contains the number of bits as in Q. Let M be the multiplicand and Q be the multiplier. When Q naught, the rightmost bit of Q is 0, we need to perform only a shift right operation and decrement the value of n, number of bits. If Q naught is 1, then we need to perform both. When we need to perform a plus m and store it in a, again we need to perform a shift right operation, decrement the value of it. So it is as simple as it is. So this is about sequential multiplier algorithm. Thank you, one and all.